It's time for On the Farm in Alabama, bringing farmers and agribusiness the latest news from Alabama Extension and the Auburn University College of Agriculture. Now here's your host, Alabama Extension Regional Agent, Eddie McGriff.
I'd like to welcome everybody today to On the Farm in Alabama, and today is my special guest. I have Dr. Audrey Gamble, who is a soil scientist with Alabama Extension. And Audrey, I get a lot of questions about soil labs and results, but one thing, when you're sending your soil samples off to a soil lab, you need to make sure that they're using the same extract. Now, here in the southeast, we use Melic 1 and Melic 3, and I know that Florida uses Melic 3, so some of our farmers in South Alabama may be sending their soil samples to Florida. And here in North Alabama, we do have some labs to the north of us that use Melic 3, but the standard for us is Melic 1. What's the difference between the two extracts?
Sure. So Melic 1 and Melic 3 are somewhat similar, but Melic 3 has another chemical added that's basically going to extract a little bit more phosphorus, and also it's going to do a little bit better job of extracting micronutrients. But what's really important is how we use that data from the soil test with 3, and that our results are calibrated to yield response so that we can actually use that information to provide some meaningful information to farmers. So at Auburn, we have decades of research, and we continue to try to do research on newer, higher yielding varieties to ensure that our recommendations for fertilizer are related to crop yield and those Melic 1 extractable nutrient values.
The other thing I think we need to mention is that every area of the country may have a different extract. Up in the Midwest, maybe the Bray; out in the far west, it may be the Olson. So these extracts were based on years and years of research on the soil types in that area. So if a farmer from Alabama decides, I'm going to take my soil sample and send it up to a Midwest lab, a lot of times it's not correlated to our soil types.
No, that's really not a good idea to take a sample and send it to a lab that doesn't have use an extract that's calibrated to our soil type. So the Melic extracts were developed for highly weathered, acidic soils just like we have here in the southeast. And so, we don't expect to have a good understanding of how something like a Bray extract would relate to yield response in our soil types.
Well, there is one outlier in Alabama, and that is our black belt soils, and we use the Lancaster or the Mississippi extract, but that's really a totally different animal.
Yeah, just about everything when it comes to soil fertility is completely different in the black belt region of Alabama. High clay, calcareous soils, some high in pH, some low in pH, and so again, that Mississippi or Lancaster extract was used in those soil types and calibrated to yield so that we could get a better understanding of yield response. And really the only places that extract is used frequently in the southeast would be the Auburn lab for our Mississippi black belt soil types, and then at Mississippi State University.
Another thing I might want to mention is we need to pay careful attention. When you look at our recommendations, they're based in pounds per acre. But some labs do them in parts per million. So how do you convert parts per million to pounds per acre?
That's a great question. I think most of the labs in the southeast do report in pounds per acre, but occasionally you'll get some reported in ppm. So it's a very simple conversion, and we won't go through how to get there, but essentially you just multiply ppm times 2 to get to pounds per acre, and that makes it really easy.
Well, I tell farmers the easy way to remember that: when you have a 6-inch depth of 1 acre of soil, there's about 2 million pounds in it. So it's an easy conversion from parts per million to pounds per acre. Now, the other question and this is probably the $50,000 question, is farmers ask me, when I send my soil samples off to Auburn and I send them off to a private lab, I get different recommendations for P and K. Why is that?
I think there's a few factors that play in there, but one of them is, there's different philosophies, I guess you could say, used by different soil testing labs. And so you could argue that at the Auburn University lab, we're basing our recommendations off of research to put out the fertilizer amount that's going to result in that maximum yield. So we have this kind of yield response curve where we're increasing yield up to a certain point, and after that point, adding fertilizer doesn't result in increased yields. And so it's a pretty economical way to apply fertilizer. Some of the commercial soil testing labs may have more of a philosophy of building and maintaining, so putting out more fertilizer so that you have to put out less later on down the road. And there's no right or wrong answer on how to fertilize. It's just, thinking about your farm and the economics of your farm and how you want to put out fertilizer.
Well, it may make a lot of difference in a year like this year, even though we have very good commodity prices. We've got some really rising fertilizer prices, so a farmer might want to take that consideration when he makes his fertilizer application based on a lab recommendation.
Yeah, I think that's exactly right. And when you look at, I haven't checked in the last couple of days, but DAP prices, for example, are about 40% higher than where they were this time last year, and that's due to several different factors interacting. But it's more of a year to be, I think, a little bit more conservative as opposed to building fertility in our soils.
Well, I know you've done some good research on cotton as it relates to potash fertilization and recommendations. Could you share that with us?
Sure. So, like I said, we've had decades of research to correlate plant available nutrients measured through those extracts, or at least estimated through those extractions, with yield response. And so we want to make sure that we are providing up-to-date and accurate recommendations with the newer and higher yielding varieties that we continually strive for. And so part of my research program is taking these newer, higher yielding varieties and ensuring that those fertilizer recommendations that we make are up to date and accurate. So we just finished up a 3-year study at 5 different locations in Alabama to evaluate response of cotton, newer, higher yielding varieties again, to additional potassium. And really what we found is that even these higher yielding varieties, when we're removing a lot of potassium, or we're removing a lot of lint from the field, we're still not getting additional response to potassium above current Auburn recommendations. And I think that's just because with our breeding efforts, we're a lot more efficient with the potassium that we do have. So that's not to say that we never see potassium deficiency in the field. We certainly do. But that can be caused by a variety of different factors, including moisture stress, compaction, and the list goes on.
I know we've done a video on that before, and a lot of times there's plenty of potassium in the soil, but there's no way of getting it up to the plant. Just as you said, it's too dry and it needs moisture to take it up into the plant. And here we've been doing in North Alabama replicated research on farm, just like they would on a research station. In other words, there are small plots, a lot of different treatments, and we've done it at the Henderson Farms up in Madison, Alabama, and there his irrigated yields are close to 300 bushels per acre. So we're getting 300 bushel yields, but we're putting a lot more fertilizer and we're not getting any more response than the Auburn lab recommendations. So one thing a grower needs to think about is that the philosophy, whether you want to build and maintain or if you just want to go out there and put the fertilizer out for the optimum yields this year. A lot of times farmers will ask me about micronutrients, and the micronutrients in the soil as done by the soil labs is not the best way to determine if you're going to have adequate micronutrients in the plant. So sometimes we need to think about taking plant tissue samples.
Yeah, I agree with that, Eddie. As I mentioned before, a lot of the soil testing methods that we use aren't very good for estimating the amount of micronutrients that are in the soil at the time of sampling. And so tissue testing can be an excellent tool to understand where you are in terms of sufficiency or deficiency for micronutrients. And unlike a lot of our macronutrients, we often can supply micronutrients through the leaf as a foliar spray. So taking those samples can actually give us something that we can make a decision based off of.
All right, we want to thank Dr. Gamble for being with us today on the Farm in Alabama, and tune in for the next edition.
Thanks for having me.